Manufacturing Technology, Module 5. Sheet metal. A plate with thickness between 0.4 mm and 6 mm is usually called as sheet metal. So, a sheet metal is generally considered to be a plate with thickness between 0.4 mm and 6 mm. Next, sheet metal working. It is a metal forming operation. It is a metal forming operation where the material being worked is in the form of sheets. The working being usually at room temperature. The work is taken place at usually at the room temperature. So it is also called as cold working process. Next, we'll move on to sheet metal characteristics. There are different types of sheet metal characteristics. Some of them are listed below. First one is elongation. Second, yield point elongation. Third one, anisotropy. Fourth, grain size. Fifth, wrinkling. Sixth, spring back. First, we'll move on to elongation. What is elongation? Elongation determines the capability of the sheet metal to stretch without necking and failure. It is the capability of a sheet metal to stretch without necking and failure. For sheet metal operation, the material is to be stretched. Okay, the material is usually stretched in sheet metal forming operation. So a high uniform elongation is desirable for good formability. So a high elongation is needed in a sheet metal working operation, because in a sheet metal forming operation, the material is being stretched. Okay, so a good high uniform elongation is needed. Next one is yield point elongation. It is the difference between elongation of the specimen at the start and finish of the discontinuous yielding. This behavior indicates that after the material yields, the sheet stretches farther in certain regions without any increase in lower yield point, while other regions in the sheet have not yielded. Next one is anisotropy. Anisotropy is the process of exhibiting different yield strength along different directions. As we all know, the sheet metal is a cold work or cold rolled sheets. Okay, the sheet metal is always a cold rolled sheet. So in cold rolled sheets, because of preferred orientation or mechanical fibering, we can always see the anisotropic property. For reducing the anisotropic property, the metal should be annealed. Annealing will reduce the anisotropic property. Okay, next, grain size. Grain size determines surface roughness on stretched sheet metal. It also affects mechanical property. The smaller the grain size, the stronger is the metal. Next one is wrinkling. Wrinkling is the wavy condition on the metal parts due to buckling under compressive stresses. Wrinkling is the wavy condition. It is the wavy condition on the metal parts due to buckling under compressive stresses. Wrinkling can be controlled by proper tool and die design. Next, the important characteristic is spring back. Because all material has a finite modulus of elasticity. Every material has a modulus of elasticity. Plastic deformation always is followed by elastic recovery. In a plastic deformation is always followed by some elastic recovery when the load is removed. Okay, when the load is removed from the plastic deformation, an elastic recovery will be followed. In bending, this recovery is called spring back. Spring back can be controlled by overbending and bottoming of the punch. Okay. Next, what is a typical shearing process? Shearing is nothing but cutting a portion from the sheet metal strip. from a sheet metal strip, we are cutting a portion, then it is called a shearing process. The phases in shearing process are plastic deformation, shear, and fracture. Okay, let us consider the shearing operation. Here we can see three figures. In that, it is written that stage 1, stage 2, and stage 3. First, shearing is the process of cutting a portion from the sheet metal strip. First, you refer the figure A. Okay. In figure A, we can see that a workpiece, that is the sheet metal, is placed in between the punch and the die. Okay. A sheet metal is placed in between the punch and die, and a clearance is provided. Okay. The cutting die and punches are produced with sharp edges. The cutting die and the punches are produced with sharp edges. The sheet metal to be sheared is well seated on the die block over the die opening. Okay, this is shown in the first figure. That is, a workpiece is placed in between a die and a punch. Okay, the die and punch have sharp edges. Okay, and the sheet metal to be sheared is well seated on the die block or the die opening. Next, we will move on to second figure, that is stage 2. When the punch contacts the sheet metal, the cutting pressure will start to build up. When the punch contacts the sheet metal, the cutting operation will start to build up. During further movement of the punch, the material starts deforming elasticity. The material starts deforming elastically. Okay, when the elastic limit of the material exceeds, the material will undergo plastic deformation and it will flow into the clearance between punch and die. Okay, when the punch contacts the sheet metal and we apply pressure on it, we can see that the material starts deforming elasticity, and when the elastic limit is exceeded, it will move on to plastic deformation and it will flow into the clearance between the punch and die. Okay, between the clearance, it is flow into the clearance of the punch and die. Next, we will move on to stage 3. Okay, during further movement of the punch, the fracture of the material begins in the line of cutting edge. During further movement of the punch, the fracture of the material begins in the line of cutting edge. Further descending of the punch completely removes the slug. The slug is the metal portion come out from the workpiece. Okay, the slug is the metal portion come out from the workpiece. Okay, removes the slug from the parent sheet metal. Further descending of the punch completely removes the slug from the parent sheet metal. At the end of cutting operation, a small portion of deformed material is punched out as tensile burrs, BURRS. Okay, we can see it in below of the workpiece. Okay, at the end of the cutting operation, a small portion of the deformed material is projected out as tensile burrs at the top of the slug and at the bottom of the parent sheet metal. Next, we will move on to stages in shearing process. Next, we will move on to stages in shearing process. What are all the stages? The plastic deformation, shear, and fracture. Okay, first of all, we will go with the plastic deformation. When the blades begins to apply pressure, the workpiece will start to undergo elastic deformation. When the blade begins to apply pressure, when the pressure is bounding on the workpiece with the help of blades, as the pressure increases, the workpiece will undergo a the workpiece will undergo a plastic deformation. Okay, in the this is the first stage. The application of the pressure will produce plastic deformation. Next stage, it is the shearing. Okay, the blade begins to penetrate. Okay, after giving the pressure, the blades will go into it. The blade begins to penetrate either side, which produces shear on the workpiece along a vertical line. Okay, and the work hardening occurs at the center. This is the second stage called shearing, and the last stage is the fracture line. You can see that in the last stage we can see the fracture lines, or the fully the fracture is occurring. The fracture lines originating from the fracture lines originating from the point of each blade meet at the center of the workpiece. The fracture lines will meet at the center of the workpiece, causing separation before the blades have fully penetrated. You can see that before the blades reach the center, the workpiece is separated. Okay, the workpiece is separated, and we told that burrs are formed. BURRS, burrs are formed. To reduce the presence of burrs, it is important that the blades are sharp. Also, it is important that they do not deflect under pressure, and that they are not set too far apart. An offset of the blades is needed for reducing the production of burrs. Okay, thank you.